this is a little bit more of a scientific presentation, but trust me, there'll be lots of minerals in it as well, and lots of mineral samples. But I just wanted to kind of share some of the research that I worked on and the way that I think on the, I've enjoyed thoroughly going in the quarries and collecting samples, but I wanted to share sort of what I think about when I go into the quarries, and I think about a very big picture. So we're going to talk a little bit about the plate tectonics, because so many of the quarries that you all go into, especially if you are based in the, Washington metro area, Pennsylvania, Maryland, Virginia, West Virginia, again and again, you're going to be ending up in serpentine quarries. And anytime you leave your house, you almost entirely cannot avoid seeing some sort of bluestone gravel. It's everywhere. And so this is actually a prime place for collecting, but it's also a great place to understand how the earth works. So what we're going to do is talk a little bit about plate tectonics and how this affects this type of mineral. So we're not going to spend too much time on this because it's not a very good slide, but you have different tectonic regimes. We have this mid-ocean spreading ridge, we have a subduction zone, we have rifting, and the most important part of this is that due to the fact that we have mathematics on a sphere, we actually end up with, every time there is a plate margin, they're virtually all in three parts about 120 degrees away. The best example that we have of this on the Earth is here. You see Africa and you see the Arabian Peninsula just pulling away. Here's the Red Sea, here's the Gulf of Aden. And then the third part of what we call the triple junction is down here. What is that? Now see how this is pulled away? This is the Bab al-Mandeb Strait here. It's only about 14 kilometers across here. And we know there's no ocean crust right in this area. So it's amazing that people didn't see this before, but when we have so much satellite imagery, it's impossible to not see that this is pulled away from here. They used to be connected, right? So here's our third arm of what we call the triple junction, which is the Great African Rift Valley. And here's the Red Sea, the Gulf of Aden, the Rift Valley. And in the Rift Valley, we have these gigantic lakes that are so big, Victoria, Nyassa, that there's no other lakes like this on the face of the earth in a tropical location. They all evaporate, but here we have an awful lot of water, and we have the pattern of rifting that shows us basically this is a proto-ocean. Now, another type of plate margin, of course, is when two of them collide, and this is our type locality for this. This is the Himalayas here. India's pushing into Eurasia, and this is the high plateau, the Tian Shan of China. And this is what we just saw right here. This is the Arabian, this is the Strait of Hormuz. Everybody knows about that recently. And look, and I want you to focus on this little raised area right here. This is the country of Oman. And we're going to look into Oman and find out a little bit about where serpentine comes from. So here is our last plate margin that's of interest for us, which is a subduction zone. And this is where the crust goes down back into the mantle, goes back into the mantle. Some of it comes back up at about 200 kilometers down. We have a lot of water here that acts as a flux, and it melts things, and we end up with this as our type locality of a subduction zone all along this west coast of South America. Not even a non-geologist can understand. This Pacific plate is going underneath. About 200 kilometers it goes down and melts. And what do we have? We have this long linear chain of mountains called the Andes, going above, second in height to the Himalayas, although actually I think highest mountain number 186 is here. 185 of them are in the Himalayas, but that's just an aside. So we have this subduction zone here. And this is the important thing about serpentinites, is that it's giving us a chance to see the mantle, to see the Earth's mantle. And the mantle here is made of peridotite, ultramafic rock rich in iron, magnesium, chromium, nickel, and very poor in silica. So this is the type of rock we're looking at, ultramafic, meaning very dark. And these are the rocks that look basaltic. So here's our continental crust, here's our oceanic crust, which is usually just subducting down into the mantle and getting recycled. But as it goes down, and if you want to think of an area where this is happening, this might be more familiar, this would be your coast of California. We've already subducted a plate there, and we have a thing called the Great Valley, which is a very place where virtually all the produce in the world is grown close to it. And that would be your subduction trench. And then you have all the Franciscan mirage and the crazy coast ranges and all the earthquakes and things going on. But here it's showing you that this is a complex system. This doesn't go down so easily. It's covered with sediments, it's covered material. And what else is it covered with? It's covered with water. So anything that's going down there is very, very complex. And sometimes it doesn't even go down, it goes up. So this is showing you ophiolite localities. And these are places where, yes, this type of subduction is going on, but it didn't go on exactly correctly. And it pushed part of the mantle and the lower crust up on the surface of the Earth where we can observe it. Many of these are here in Africa, which I just showed you, and especially Oman. We'll go to some slides of actually visiting Oman. Cuba is a fantastic place for that, and other places. And also, just keep in mind here that some of these places that we see are not really active subduction zones at all, up in the Alps and things. So part of this is something that's happening right now in the Arabian Peninsula and in Africa. Part of this is something that's been happening for a long time, probably on probably on the order of 3 billion years. So going back here, this is this little mountain range here by the Straits of Hormuz in Oman. And this is just another picture of it so you can get your bearings. And here it is. This is this ophiolite. This is a massive piece of the Earth's mantle that's been pushed up, and it's been pushed up in a very, very arid area so that we can see it. And you notice right away how weathered it is. Part of this is from rain, because it is very close to the coast and it does get some rain. But most of it is because these rocks are always exposed to so much seawater. And so they're altered almost as soon as they're created. This is an interesting thing here. These are called the pillow basalts. Many of your serpentine rocks come from these pillow basalts. And if you can look at this and think of some lava that was squeezed out of a mid-ocean spreading ridge like a tube of toothpaste. This is toothpaste lava. Here's another place where this guy's standing here. This is the mid-ocean spreading ridge. Some lava comes up, the ridge spreads, and it makes a thin layer of lava. Then it spreads again, and it spreads again, and it spreads again. And so it makes these layers, and there's a central location where it goes. And this is, in fact, some of you may know this, some of you may not. I'm sorry if I repeat it, but this was the way that we figured out how the mid-ocean spreading ridges worked, and actually how plate tectonics work, because due to a lot of wartime minesweepers would go across the ocean, and they kept noticing that and they would tow magnetometers, and they kept noticing that the magnetic field would reverse. It would go back and forth, back and forth. And we now know that the Earth's magnetic field reversed. And so as the mid-ocean spreading ridge went on for millions of years, it would record the magnetic either normal or reverse polarity in the lavas, and that's what was read. And that was basically the nail in the coffin that changed geology forever, when people said, okay, plate tectonics is the way it works. And then we have some massive lava here too. And this is an altered piece of the mantle, a huge block. Here's a couple more. I guess these got switched up. A couple more pillow basalts. They look familiar if you've ever been to Hawaii too. And then this is showing you how this part of the mantle has been pushed up underneath the crust, but it's still all on the surface. So what is really in these rocks? This will be familiar to you, the San Carlos, Arizona type location. The major mineral and component of the mantle is olivine, this magnesium silicate. It is a gemstone peridot, but as we saw before, we didn't see anything that looked beautiful like this. This particular situation with San Carlos is a very, very fast volcanic eruption that is nowhere near the ocean, and so it isn't serpentinized. These are some of the other, I gotta move this. Oh, thank you. Gotta move this. Okay, we have other high pressure minerals, and of course these are high pressure minerals because they come from the mantle. Some diopside, orthoperoxenine, garnet, and spinel. And these are some nice pictures of some gem quality diopside. This is a gem quality enstatite. And of course, the pyrope garnet. I know many of you are very interested in garnets, and this is a high pressure metamorphic rock that has this beautiful garnet in it. And again, it's a high magnesium garnet because the mantle is just filled with magnesium. And then the garnet that everybody loves, which is the chromium garnet. These garnets are uvarovite garnets, come specifically from these mantle peridotites, lizardites, and such, because there's a tremendous amount of chromium down in the mantle. Most of the world's chromium deposits come from serpentinites, come from these altered peridotites, and we'll see some of the chromium mineralogy and some of the mining coming up. But this is perhaps for me, this is one of the most beautiful minerals that I know. The color is spectacular. And if you see it in person, it takes your breath away. So going back to these ophiolite localities, we also want to keep in mind what I said. Some of these in the United States are not shown because this is mostly telling you more recent ones. Thetford mines, that's probably a meteorite impact. But we also see something in the Alps. So why is that up in the Alps? It's because this has been going on for a very long time. So we have two types of serpentinites. We have some that, here, indicates here the Mediterranean. Very, very complex area. We have some of these things that we talked about that were down here that just happened the other day, geologically pushed up. But we also have things in the Alps and the Apennines and stuff where we have major amounts of serpentinites, and they are in metamorphic areas. So you have to think of them as very old areas of subduction, where subduction is no longer happening anymore. Everything has been changed and metamorphosed. But some pieces of that ophiolite, like I said, some accidental pieces of the mantle that are shoved up on the surface, well, it happened in the past too. And then it gets incorporated into other metamorphic rocks. So this plate tectonic system, this is showing you what's happening now, but you can imagine that this could happen now. The system could completely be buried, be metamorphosed, and pop back up as some of the things that we see in the eastern United States. So we'll just read this. What happens when the mantle peridotite and associated basalts are metamorphosed in the presence of seawater? The result is serpentinite, the rock type composed of the minerals serpentine and associates. It's very common in the Appalachians, seen all around us in Vermont green marble. Here's a nice picture of this. Green, quote unquote, green marble is actually serpentine, and bluestone road and drainage gravels, which I said there couldn't be any of you who have not seen that. So you're mostly seeing serpentine. There's some chlorite, talc, magnetite, chromite, stitchite, and this gives you an idea of what the serpentine looks like. This is the chemical formula of it, and this antigerite quarry is very, very common. This is seen again and again and again in the quarries in the Piedmont that many of you have visited, and here's a picture of a very large mine in Vermont, which is some place that we worked. And this is an asbestos mine. Asbestos has gotten kind of a bad name, but there's no real reason for that. Yes, it's not particularly good to breathe it in, but it's still an incredibly great product. We don't have a lot of things that are as heat resistant and as flexible as they are. So it's still very, very useful. And here's another picture of this, and you can just see the you can just see that same blue-green color. All the rocks are this blue-green color. They don't, everything that's serpentine is green-green. So here's your chrysotile. This is the same chemical formula, but it has the asbestos form. Asbestos form means it's fibrous. And this is like I said, extremely valuable mineral. Not so great to breathe in, but we still don't have anything that's better for fireproofing. And lizardite is the form that some of you would be familiar with. It's very common, and it's quite often used for building stone. It can be used as a gemstone. Get this up here. And then bowenite is the form of our serpentine. It's very, very clean. It doesn't have a lot of manganese. It doesn't have a lot of iron. It mostly just has a magnesium. And these are type localities for bowenite, or New Zealand and Rhode Island. And this is polished as a type of jade, and it can be used for a lapidary stone. It's very, very interesting. And here is a mine, and this is in New Caledonia. So now we're going to switch over a little bit and say, well, what happens to all that uvarovite? We saw that the peridot was metamorphosed, and the diopside was metamorphosed and basically turned into serpentine. Well, what happens to all that chrome? Well, all that chrome turns into the world's best chrome mines, the world's only chrome mines. If you want to find chromium, you got to find serpentinites. Those Ophiolites that are pushed up, they push huge reservoirs of chromium up on the surface or close to the surface where they can be mined. And as you can see here, this is not a deep mine. This is halfway between a deep mine and a strip mine. So it's basically similar to the mines that you see for copper in the Southwest in Arizona and such. And they're pulling all the world's chromium out of this. Chromite is the only chromium ore. I'm not saying it's the only chromium mineral, but the definition of an ore is that it must be economic. So this is the mineral that is economically valuable in terms of producing chrome. Other minerals that might have chrome in them it's too difficult to smelt them or too difficult to mine them. So here's some chromite. And then this came from this area too, which is another place where we worked. This is Soldier's Delight in Baltimore County. Some of you may have been up there. You can see this is a picture of it. This is a picture of the old mine shaft and a picture of the vegetation. And why we put this here is because this vegetation looks like an arid place where it didn't rain very much, but it looks like that all the time because the serpentine soils are very poor soils. They don't produce field crops very well. They don't grow grass very well. They grow their own particular kinds of plants that are adapted to this, and they are adapted to having relatively high magnesium, but low calcium and low iron, and kind of a thick clay soil. But this is a very interesting, Baltimore and Maryland fact that from these dates, almost all the world's chromium was coming from Soldier's Delight in Baltimore County. And Sykesville produced copper, and that copper is the copper that's on the Capitol Dome. But this is what is interesting here. I'm saying this is Precambrian ultramafic rocks. These are multiple times that these rocks were metamorphosed. So these took a long trip from being an ophiolite, but at some point, this part of Baltimore County was in fact a subduction zone. And here's another picture. Many of you may have collected these. So they're all in Maryland, Pennsylvania, Delaware, Piedmont. And this is just a little bit different. This is magnesiochromite, which is a magnesium chromite, and it is also found in Soldier's Delight, but this is the type location for this particular mineral here is Fulton Township in Lancaster County. And one of the most interesting places that some of you may have been in, and I was lucky enough to go in there, but we're not really doing it anymore, is the Rockville Crushed Stone Quarry. This is a serpentine quarry, which has some of the most interesting minerals in it that you can find in Montgomery County. This beautiful grossularite garnet, which is a high calcium garnet. But for some reason, it ends up in the serpentine. And the reason is because these are what I'm saying, those Alpine ultramafics, those heavily metamorphosed ones. So what has happened here is that there's one of those ultramafic bodies has been metamorphosed, surrounded by some limestone, surrounded by some calcium carbonate. And so at the contact of the serpentine and the old calcium rock, which is now also heavily metamorphosed, we see this beautiful kind of cinnamon garnets, grossulaurite garnets, high calcium garnets. And of course, talc can be very simple, but it can also be very beautiful. And the talc this talc is actually from the Rockville quarry, and it has some of the most interesting talc samples that you can find locally. We also see clinozoisite, epidote, and very rare is McGinnisite. And the reason is because there's simply not a lot of copper. Most of your copper deposits come from entirely different geology. It happens sometimes, but see what I see here? This is tertiary mineralization. What has happened is that we have the original ophiolite, which is the thing that I said, a piece of the mantle that's been pushed up. Then we have hundreds of millions of years pass with multiple metamorphisms. And then we have another system coming through, a later basalt, which has made there's been some fractures, some basalts run through, some hot fluids have come through, some hydrothermal fluids have come through, and done a secondary alteration on this. And that's how you end up with some of this copper mineralization that from time to time you will observe in a serpentine quarry. So, and then every once in a while we see this metaperoxenite. So this is how and this is a very interesting one from the Shetland Islands. They can have all these different minerals in them. But again, it's a mantle rock that's been metamorphosed, and this has enough chromium, but it's not considered a chromium ore. This is one of the things that I was able to observe in Tasmania. These are not my samples. I'm sure you guys have some nicer ones than this, but this is a magnesium chromium mineral that's again hydrated, because everything is in the serpentine family is hydrated. And this is a famous lilac color. And this is a beautiful lapidary stone and a beautiful polished stone that's famous worldwide. So serpentines account for 60% of the world's nickel production. This is a tremendous amount. So here we have the Koniabo Massif in New Caledonia. That's between Papua New Guinea and New Zealand in the Coral Sea. And you can see that this is, now you know what these things are like. This is a huge ophiolite that's been pushed up. And it's mined in laterite being that nasty tropical soils where it's been raining and raining and raining and in a humid climate, and it washes almost everything away, and it just leaves whatever is not very soluble. And so this is the nickel company, and this is New Caledonia is one of the world's leading nickel producers, as is Cuba. And these are some of the minerals that you have there. The garnierite. Here's a typical sample that you may find in a quarry, and here's a collectible sample that comes from a fracture zone where these botryoidal crystals have been able to form with a little bit of space. And I apologize for this. I'm not quite sure how to pronounce that. Nepoite. The type location here is in France, but again, the beautiful specimens come from New Caledonia, and you see the botryoidal growth here where you've had a fracture zone, and this can grow out into space a little bit. It's similar. Those type of forms are similar to what you see in the large crystals in a geode or something, where there's some space for them to grow. So every once in a while in your serpentines, you do find nickel sulfides. Here's some millerite and pentlandite. They're reported. But I'm saying other than Archean greenstone belts, serpentinized ophiolites per se are not primary sulfide sources. Well, why do we find the sulfides there? Well, the sulfides are there at the metamorphic context, because remember I showed you the picture there where of the mid-ocean ridge lavas coming up. Well, the mid-ocean spreading ridge is sometimes near the ophiolite and sometimes far away. And sometimes the entire plate tectonic regime from an ocean spreading ridge to a subduction zone, especially in small areas and island arcs, such as in the Philippines and Japan and such, sometimes all of that is completely compressed and folded up into one giant metamorphic area. And so we used to be unbelievably stunned by massive sulfide deposits, the type locality being Jerome, Arizona. Huge funnel-shaped, massive sulfides, extremely valuable ore, and there was no good explanation for it until we began to send these submersibles down, see the spreading ridge, and see the massive stacks of sulfides. You've probably seen those worms that live in the sulfide that are waving back and forth at the spreading ridges in the hot water. Then bingo, of course, yes, we know exactly what's happening. Those are the stacks of sulfide minerals that come from the spreading ridge. And so Archean greenstone belt is something that you see in a shield. The best known one is in South Africa. And these are very, very old areas where the plate tectonic regime was hotter and moving faster in the past, on the billions of years ago, but essentially was the same. And if you would like to see the oldest rocks in Maryland, you can head out I-70, just past Frederick and Braddock Heights, and there's a bridge that crosses over, and you see a green rock with some white veins in it, and that is a greenstone belt that is Precambrian, the oldest rocks in Maryland, and that kind of greenstone is what we think is some sort of similarity to the ophiolite. It's a metamorphosed oceanic or mantle rock, and you do in fact find veins of sulfides in those rocks, and that's, like I said, everything in the plate tectonic zone has been compressed, has been folded together, and given you a complex picture of what's going on. Okay, and then this is our most interesting member of the serpentine group. There's a lot of different serpentine minerals, everything from asbestos to the lizardite that we saw that is fairly common. And this is aimsite, and it comes only from this mine that I know of in the Russian Urals. And so then you say to yourself, okay, now I understand what's going on. We definitely are not having any type of subduction zone. We don't have the Philippines. We don't have the west coast of South America. We don't even have the west coast of the United States and Canada going on right now. The Urals are right there in the middle, demarking the border between the Russia that we call Asian and Russia that we call European. It's kind of the marker for what to differentiate Europe from Asia, or else we just call it Eurasia. So then of course, this situation was a subduction zone a long time ago, and this was some very, very pure mantle rock, similar to the San Carlos Peridot, that was metamorphosed in a situation for some reason or another where the water content was relatively low. So you didn't get that kind of messy sort of serpentine. You got these beautiful crystals which have this purple color just because the balance of aluminum, chromium, magnesium is just there. And I said only magnesium results in a clear gray color. Once this is crapped up with a bunch of iron in it, no, you can't get this. So this is a kind of a situation where maybe the metamorphism started and it was uplifted and it continued to be compressed and compressed and compressed, but it was dehydrated. So the last thing we're going to say is, what do these soils look like? Well, if you live in Montgomery County, or you live in Howard County, or you live in nearby, you may have seen some dirt that looks kind of like this red soil, and it doesn't grow very much. and it's not very good for gardens, and you have to add a lot of things to it in order to have a nice garden, nice vegetables, nice grass. And this is indeed because anything that's ultramafic weathers very, very rapidly. And when there's a lot of rainfall, you end up with a laterite, which is soil that doesn't have much in it but heavy metals and aluminum, a lot of aluminum oxide. Bauxite, for example, aluminum ore comes from laterite soils. So these soils are low in calcium, they're low in organic matter, they're low in iron. They have a lot of their magnesium, but a lot of it's locked up and it's not available to plants. And they can have a tremendous amount of chromium and nickel in them, which in most cases stunts the growth of plants. But all over the world, and some of the most interesting ones are in Cuba and right here in the United States, and all over Turkey and the Mediterranean, there's what we call serpentine endemic plants. And they've been growing on the serpentine soils for a very long time, and they have adapted themselves to have such high metal contents, especially nickel, that the nickel content in these plants is on the order of 2 or 3% by dry weight, not by wet weight, by dry weight. Well, that's about the same as an ore. So we took a look at some of these plants, and this is the one that was the most productive, Alyssum murale. And this alyssum is not too different than a garden plant that you could get in a garden center. It's a perennial. It's pretty winter hardy. It grows well. But this particular Alyssum murale just seems to love nickel. It grows well, and you can grow this plant. You can cut this plant down, and you can ash it in a furnace, and you can actually cast an ingot of nickel out of what's left. And so it gives an opportunity for some countries and some locations that have these very poor serpentine soils to mine the nickel without even using a shovel or any type of anything at all. You just use the plants to do it. There's been some work. There's plenty of other plants. For instance, there's some trees, some tropical trees in the New Caledonia area and such, in Papua New Guinea, that have so much nickel in their sap that the sap is green. And there's some other plants and other types of alyssum that work very well too. But this one is this one grows great and doesn't need a lot of fertilization. And it's just an option for people that would like to do something with their land. Perhaps they can, mine it for nickel, phytomine it. We have some phytomining that's done for zinc. Also, there's some plants that can hyperaccumulate zinc, is what it's called. Everybody asks if you can get lead out of the soil with some plants, and the answer is no. Plants don't like lead any more than anybody else does, and the best thing to do there is just put a whole bunch of lime on the soil and raise the pH so that the lead is not as mobile. So that's all I have for now, but I do have a couple real examples of some of these minerals if we want to, which if you have some questions, then I can pick them up and show them to you. We can go back to let me go back to exit, go back to this. Okay, it worked.
Fantastic, Leigh.
Okay, thank you. I know Kenny loves this because he goes in all those quarries.
I was just in the Hunting Hill quarry. We got a special invitation from the quarry out there, and we had a small group of us from Montgomery County went in there, and I was one of the 10 lucky people.
You're so lucky. Yeah, let me make this light a little closer and see if this will help. It's not, you really need I think a specimen light for this. But this was one of these, I'm not sure. Yeah, this is not really going to work, is it? I don't know.
Looks like a rottingite.
Put it up a little closer.
This is that giant rostrulite. Oh, see this. Let me put another weight here, but luckily I have a rock for that. See if this will work.
Yeah, get it up close and see what we can see.
Yeah, I just need a good, see if you can see see if you can see the giant garnet there.
Yeah.
Huge.
It goes from here to here.
Oh,
Yeah,
yeah.
hold it a little further away from the, there you go. Yeah, a
There
little,
you go.
yep.
Oh,
So that's a giant grosserite garnet from that Hunting Hill quarry. Like I said, that was kind of unusual, but that's because the quarry had that contact between some limestone rock and some serpentine that was all metamorphosed together.
Hmm.
But when you see these garnets, you know that there was a pretty much, there was definitely some high pressure. And then you all know these, right? San Carlos peridotite.
Hereditary.
The peridot, the gem quality peridot that they have, that's coming up in the lavas. Let me see if I can put one. I'm going to put one more light up here too. The wiener dogs listened to the whole thing. They thought it was fascinating, or not.
Mhm.
Yeah, that's better. See all we have the crystals in these nodules. Almost everybody's seen one of these before. There's some other places in the world that have them. And so that's kind of the sad thing about it. We have these beautiful, beautiful gem quality crystals, but almost everything that we see is actually serpentinized. And the reason is because this particular rock will come up in a very fast volcanic eruption, similar to, you had a diamond, somebody talk about kimberlites, right? The San Carlos peridotite is similar to kimberlite, really fast lava pulled some pieces of the mantle up quickly in a dry location, but 99.9% of the time, when you get a piece of the mantle coming up, you get a bunch of water associated with it. So the stuff is metamorphosed and altered immediately. And then this is yeah, that's not going to work. That's a nice diopside, but this one will. This one will, because we all know, every once in a while you pick up one of these, right? See the fibers that are coming out of the top there?
Oh, yeah.
And all the fibers that are coming out of the top. It's always, I don't know that anybody ever looks for that in the quarry, but I do. If I'm there, I look for, doesn't that work?
Antigerite.
Yeah, this is the antigerite at the bottom, and the chrysotile is on the, I'm not sure. Yeah, there you go. That's the chrysotile that's coming right out of the top, the fibers. Very, very pretty specimen. And then of course, then a lot of times it's just huge bars. You can see it's all fibers. It looks like,
That andesite.
no, that's all chrysotile asbestos. Right out of the asbestos mine.
Wow.
This is what your normal serpentine looks like, the lizardite. And this is hard and platy. It falls apart easily, but it doesn't quite have the fibers. This is a little bit fibrous. It's just getting there. But on the other side, you can see that it's very blocky. And this one right here is one of the ones that had you see these kind of faces in the quarries. These are where you find the unusual things such as the McGinnisite that have copper in them. There's not usually a lot of copper, but as I explained, that's kind of a tertiary system where you've already had something that's been metamorphosed immediately when it hits the seawater, then again through the millions of years that it's been metamorphosed regionally, and then again it's been altered by a late stage hydrothermal action, which could be something such as in the Frederick Valley, the rifting, which is Triassic in nature, much younger than the rest of the rocks from the opening of the Atlantic. So something like that, or something that was relatively recent and brings a little bit of copper into the hydrothermal system, and it deposits very quickly in the serpentine. All right, I think that's good. Any questions?
Hi, I'm Ken Zone from Montana. Can you hear me? I've got some samples here that I sent to John by email attachment today. And these are what I would call the gemmy variety. Used to have the varietal name Williamsite until they decided to dump it for just antigerite. Pretty nice material. Most of you who have ever, I'm almost 88, so I've been around for a while, but collected at State Line Pit in Maryland. And here's a piece of the State Line material.
Oh,
This is a
Cool.
translucent carving.
Oh, that's really pretty, yeah.
And hopefully this will end up at the Smithsonian. It's probably the nicest piece that I've ever seen in terms of translucent. It has been XRF'd. I know all about it. It is not microfibrous at all. It's massive, even at a couple microns. There's no laminar material to it all. It doesn't undercut. And this is from the State Line Pit. Then there's a piece of rough. This is the typical rough from there. And you can see it's also pretty translucent. And there are bits of chromite in it, of course, because
Yeah,
it was a
that's something to
chromium
do.
mine in the 1830s up until, well, it was reopened several times, World War I time period. No longer able to collect there, but I have lots of material, all the different minerals plus the rough. It does make a beautiful stone. And if you want to see a nice photo of each of these pieces, ask John if he can dial up my email. There are several attachments there with these materials shown much better light. And the summary of where I used to collect and why I love this material and how I found the material is in one of your newsletters in December 2013 on page 16. There's an article there. I hope to get back to visit my family in Philadelphia area. And when I do, I'm going to try to get into Maryland, and maybe I'll be able to come and give a presentation on this material to your club.
Well, it is beautiful, and some of this was, of course, utilized as, the jade is kind of a
Yeah.
all-purpose term. Some of it was in fact
Right.
used. It's not jade, it's not there,
No.
but it has been used as jade and carved, and the translucent material is very beautiful. I agree with you.
Yeah.
And
It's not hard enough to meet jade grade, but it's a little harder than you might think for serpentine or for
Well,
typical serpentine mineral.
serpentine is just very interesting because it does have so many different mineral habits,
Mhm.
and we truly do not know exactly what causes it. You can find some mines that have every sort,
Yep, exactly.
and exactly, so you would have to assume that it has something to do with, just as a yard or an area can have microclimates, there must have been some sort of analogous to microclimate in terms of that metamorphosis. Was it a little warmer? Was there a little more fluid? Was there a little more magnesium? Was there something there that
Right.
caused it? And some mines are known for asbestos and some aren't. But generally, I would say when you see something that's clear, it was like that last mineral from the Urals that you've seen. It didn't have as much water around it.
Right.
It didn't have as much water. It was able to start the process and be hydrated and then finish the process of crystallization without being bathed in seawater.
Well, this material that I showed you some photos of is about a 2 to 4 inch layer surrounding a potiform deposit of chromite
Mhm,
ore.
mhm.
It's almost vertical, goes down about 700 feet. That's the State Line Pit. And they used to cob those pieces off and they left them on the ground because they just wanted the chromite ore, and they took them by wagon to Baltimore and shipped them to England for their source of chromite in the middle 1800s. There's a good article on that particular mine in Mineralogical Record, volume 12, number 3, May, June 1981. And that's the primary reference article to this particular location. And I have a lot of material. I love it. And I dug a small piece of this translucent williamsite out of a warm asphalt that had just paved a parking lot at a motel at Aberdeen Proving Ground, Maryland. It was like 100 degrees. I stepped out of the car onto that new asphalt, and here's this beautiful green, dark green thing looking at me from the asphalt. I dug it out with my car key. It was about the size of my fingernail. It took me a while to trace it down, but after visiting Cedar Hill Quarry, talking to the locals, I finally figured out where it came from, and I had permission to collect in there for about 4 years. So there's a very nice material there, and hopefully I'll get back and give a presentation to your group in person sometime.
Okay, that's interesting because I was saying that's what happens. There's so much of the bluestone gravel everywhere, and I was saying that typically the serpentinites are not filled with sulfides, but there's always some bluestone gravel that has some pyrite and some, I can't think of the, and some bornite and some chalcopyrite in it. And I know I would send my kids out to pick through the gravel, and they go, Mom, look at, I found this. This beautiful. I found this. It's great. And so if you're just sharp-eyed in gravel, you can often, the same thing when you see some of the Eastern Shore gravels, every once in a while, there's some nice fossils in them. If you just sit down at a swimming pool drainage, ask me how I know, to look through the rocks, can see something. I just, last week I was in Revelstoke in Canada, and the Columbia River goes through there. And so there's massive gravel bars in the river there, and the water level was quite low. So I took a walk through there to try to find something interesting and bring it home. You know, every rock for miles around is down in the glacial gravel there. And I recommend doing that. I'm pretty sure I found some sphene or titanite, but most of it was pretty ordinary. But gorgeous. And what else do we have? See if this comes. Yeah, he's got a flashlight. That's the way to do it. I think this is a better example. You recognize this lava with the peridot in it. Everybody recognizes that. So that was our kind of, and sometimes, of course, it's it's diopside, Hedenbergite. These nodules just look like this. They're not that beautiful, but trust me, this thing weighs about 5 pounds just in my hand. It's very, very dense. And okay.
I also have a flashlight. I don't know whether I can do this without distorting things, but that's the carved piece, and the color is spectacular. Yeah. Well, you can see a nice photo of it if you can find the email I sent this morning. You'll see it there.
Ken, your pictures also in the Ken Zahn photo gallery on Mindat.
They are indeed, some of them. Yeah.
That particular Williamsite is.
Yes, it is. It's there. It was about a hen's egg size piece. I had it in my pocket after carting it around for, I don't know, 3 or 4 months because I loved it. So just a piece of rough. And I took it to Tucson Gem and Mineral Show and came across a Taiwanese dealer, and I just pulled it out. And of course I challenged him to figure out what the hell it was, because it's obviously not jade. It's not this, it's not that, it's not the other. And I said, and he said, I can have that carved for you, which is what I decided I did want to do with it. So I simply handed him the piece. across the counter. And he took it to a carver in Taiwan. And the carver sent me back that piece carved. It's got a tree and an ibis bird and leaves and limbs. And he's just put it in a mailer envelope with a bill for like, I don't know, $40. And I sent him a check and I have my carved piece. I've had it scanned a number of different ways to look at the surface to see if in fact one is, whether it is or is not microfibrous. It is not. It's massive, very smooth, right down to the smallest you can measure. There it is, right there.
Mhm.
Somebody pulled it up. Thank you.
Yeah, it's very pretty.
Well, this is the first time I've signed in. I feel myself very privileged to be able to see some of these presentations. And I hope to get back there. If anybody gets to Montana, look me up. I'm in the Bozeman Gem and Mineral Club and was previously president of the Northwest Federation of Mineralogical
I go there just
Association.
about every year, but it's for skiing.
Well, good. Come to
Tim?
Bozeman and we'll talk.
Tim? Tim,
Yes, yes.
before you leave, I wanted to say hi. I haven't seen you in years.
Well, that's true. You haven't.
So
Well,
it's
you
good to
look
see
a
you.
lot younger than I do, so.
Yeah, well, I'm about 10, 12 years younger.
Yeah, well, you should look younger. I'll be
But
88 in May, but I'm still perking along, so.
Oh, that's good. Paul and I are also. We're both not as fast as we used to and not doing as much collecting, but when I saw you there, I just had to say hi.
Well, 10 minutes before this opened, because I was a little late signing in, I had just driven in from Madison River area where I collected bright, beautiful, incredibly beautiful blue moonstones.
Oh,
Hard to find, but they're there. So I'll be working those up as soon as this is over. I'll clean them up and ooh and ah about those.
Well, thank you, Ken. That was a fantastic addition to Leigh's presentation.
Yeah, I don't have one of those, but this is, see if this comes, see, this looks like nothing. But if you turn it on the side, it looks like nothing. Turn
Yeah,
it on
cool.
the side. This
Cool.
is actually a gem quality diopside that
Yep.
comes from one of these serpentinites, and you can see how it's the fibers in it.
Mhm.
And if you just see this rock on the outside, you don't know. And these are some of the beautiful minerals that you can find in the serpentine quarries. And if it gets a little bit better, one that my father-in-law had with massive bright green diopside that you can cut and polish, similar to what it's very similar to the color that you have, has got a
Right.
little bit of chromium in it to make it that beautiful color, and grows with, you know, with less water, more slowly, and it's almost an emerald color. It's
Correct.
shockingly beautiful. I like it. I like green.
Mistaken for emerald too, sometimes in small
Yes,
pieces.
yes. Same with the diopside. It can be taken for emerald. So I guess anytime we have a opportunity to go in a quarry, we always want to try to look for some of that. And because it's of no interest to the people who are mining in most cases.
Right, but it's hard to get access now.
I know.
Sure.
That's never going to get any better. So
No, at least with a
especially if
PhD
you
in
wanna
the
take
field, you
kids
have
in
an
there.
option to talk your way in. My PhD's in
yeah.
organic chemistry. That's not going to get me into Cedar Hill Quarry.
Well, you got to have some reason to get in there, like doing some research or something. But yes, it helps. And so, and I mean, I'm hoping that if you guys need to get in quarries, just having a little bit of the background of where the stuff came from, it can't hurt and it might help.
Well, thank you, Leigh. That was
Okay.
a fantastic presentation. Do we have any questions for Leigh before we sign off?
Anything else?
Well, I enjoyed it so much. Ken, go ahead.
Well, I have one question. Lee, you mentioned something along the lines of chrysotile and asbestos in general having kind of a bad name, that not all of it's bad. Can you talk about that just a little bit? Is all the fibrous asbestos hazardous?
Of course, the problem with the fibrous asbestos, I mean, we still have ads trying to get people to, you know, there's just like cigarettes, there's still money, pools and pools of money that places like Johns Manville had to pay for workers who are exposed to asbestos, because especially in shipyards, any place that needed fireproofing, because asbestos is woven into fabrics. You have heavy duty insulation, fireproofing for furnaces, fireproofing for electrical, and fireproofing in very, very critical situations such as submarines, where once there's a fire that starts, your life is over. You know, you just don't have a prayer. And of course, asbestos was used in tiles for houses too, to fireproof them, and older houses still have this. Asbestos was even used as insulation. So the problem is not the material. The problem was that people were using it without a proper covering of their airways. Now we use respirator systems for anybody who's doing this, and it's very similar to spray painting. People used to go out and spray paint barns and spray paint auto chassis and stuff without a respirator, just breathing the paint in. And of course they got all kinds of cancers, you know, a lot of bladder cancers, a lot of lung cancers and things. So we don't allow that anymore. So most of this happened in the past. Now, and so when you say something about asbestos, and you get a lot of negative, oh my God, they're horrible, you got to shut them down, we can't have asbestos. You get a lot of negativity from people who don't understand that it just has to do with, you know, improper protection of workers. Okay, it's a workers situation, it's not a product situation. If you have nothing else that is basically a rock that you can weave into fabric, there's no substitute for that. It's just so refractory. So the careful use of asbestos is not going away. That's all there is to it. But now we also have, but there's also been a little bit of a scam. Like he started to say our house has the asbestos in it. Now there's, especially the government has a lot of old buildings with asbestos, and they just refuse to tear them down. They figured that they have to leave them alone because it's so dangerous to tear them down, because of asbestos is going to go everywhere. So property that could be developed into something else, or buildings that could be renovated, are simply sitting there, you know, unoccupied and rotting. And eventually the asbestos will be released to the environment. And it's become a multi-billion-dollar industry of trying to take down buildings, with older buildings with asbestos, you know, around the plumbing pipes and stuff wrapped around it, turning it into, well, this job is going to take, you know, millions and millions and millions more, because we have to have a hazmat crew and we have to dispose of all this stuff. And most of the time, just somebody who's just going to do renovations to their own house does not have a long enough time period of exposure to cause any kind of negative problem. You protect yourself from a respirator, you get it done. It's somebody who's been working 30 or 40 years in a shipyard installing asbestos around pipes with no respirator on it at all that has these problems.
Mm-hmm. Thank you.
Anything else?
Yeah, I have something. I wish, to me, it kind of looked like jade, and I didn't get it on mine. I'm embarrassed to admit I got it on Etsy. Cost me about $75. It's shot full of pyrite. And I have a stupid question to ask. Is there any difference between serpentine and serpentinite?
Yes.
Serpentine is a mineral group.
Okay.
Serpentinite is a rock that contains serpentine.
Predominantly serpentine.
Yeah. Yeah, but it can have other things in it too. It can have talc, it can have chlorite, it can have pyroxenes, amphiboles, can even have a little quartz, little. So serpentinite is the rock type, just like you could get some. You could find a granite pegmatite and you could have great big crystals of quartz and tourmaline. And those would be quartz and tourmaline, but the rock is a granite pegmatite. It just so happens that because of these minerals are highly hydrated, they weren't very difficult for the original prospectors to identify them and separate them. So they kind of just said, oh, that's a serpentinite. That's that green rock that we keep seeing. But it's a great rock to, it makes great crushed stone. So that was one of the, and of course they found asbestos and they thought that was really great because it was a fantastic product. So the crushed stone and the asbestos made it worthwhile. And then with a little bit more digging around, then people began to realize, there was chromite. And then we began to realize that not, like I said, 60% of the world's nickel is coming from a couple of these relatively recent ophiolites that are just chock full of nickel, mostly the garnierite.
Well, this thing is full of pyrite. Is that kind of unusual or standard or?
Well, it's kind of hard to say what it is. I mean, no offense, but it's about as good as me holding that stuff up.
Yeah.
Yeah. But a green
Feels like jade. It's totally.
But it's not unknown that there could be pyrite in a serpentinite. It's not unknown at all. But I was just trying to say that the nickel sulfide, like the millerite there, this is the nickel ores that you're mostly getting are nickel, the garnierite. They're mostly a nickel silicate. They're not so much the sulfide. But it doesn't mean there aren't any. There can definitely be some, especially you can have a serpentine and you can also have a metabasalt, and that might just be a metabasalt, and that typically has a lot of pyrite in it.
Leigh, you had mentioned millerite. I had discovered that up in Lancaster, Pennsylvania, there's a place to collect millerite. Do you know anything about that?
I don't know too much about it. I just know that serpentine quarries are common, especially in that area, and that pentlandite and the millerite, they have been reported in those quarries. But I just didn't want anybody to. They definitely have been reported, but that's not your place to go rushing out to find it. You'd be very, very lucky to find one of those millerite pin cushions, put it that way. Those are more common. Those are more common in a massive sulfide, like, or in a copper porphyry type of environment, more like a Arizona environment, or in some of the big sulfides in, for instance, in Ontario, the Thetford mines, which is a more complicated situation where there probably is some serpentine, but almost certainly there was an iron meteorite, that hit there. Almost certainly there was a very, very large meteorite impact. And of course that they're iron nickel meteorites, because there's almost pure nickel, just like sometimes you can find native copper. There's almost native nickel there. It's just such a high concentration. So but I could certainly look into it because I could learn more about it. I've never found one of those pin cushions. I've always just found a little bit. But you see what I'm saying? It's like almost all the time your sulfides are going to millerite with the needles there is almost pure nickel sulfide. So it comes from a concentrated nickel area, and it doesn't have a lot of iron in it, because as soon as it gets a lot of, there's some nickel, there's some manganese and whatever in pyrite, but it's mostly iron. But if you get a place where you get the nice minerals in a location where it's not contaminated with a lot of iron.
Very good. Well, thanks